In this video, we present DMN IDP, a multifunctional interactive DMN decision modeling tool. This is research done by Simon Vandevelde and Joost Vennekens, researchers at KU Leuven, the Nijr campus, Department of Computer Science. First up, we're going to talk about DMN. What is DMN? DMN stands for Decision Model Annotation. It's a standard designed to express decision logic. It has been designed by the Object Management Group, the same group that publishes the UML standard. In DMN, we create table-based representations of decisions. In this way, we try to increase readability of decisions. We then group these decisions together in decision requirements diagrams in order to showcase how these decisions are interconnected. This improves traceability of decisions. In this way, the decision requirements diagram represents the structure of our decision model. In it, we can show inputs, decision tables, knowledge sources, and more. In the example, there are two inputs, namely age and years of service, and there are 4 different decisions. We use these decision tables to decide our outputs, here in blue, based on the inputs, here in green. Every row represents a rule of our decision table, and every column represents a value. For example, here row 2 states that if the age is between 18 and 60 and the years of service is below or equal to 10, then eligible 5 will be no. The behavior of a table is defined by its hit policy. In this example, this is the unique hit policy. But there also exist many more. Now that we have explained the basics of DMN, we will now explain a bit more about the IDP system and the interactive consultant interface. The IDP system is an implementation of the knowledge-based paradigm. In this paradigm, we store knowledge in so-called knowledge bases. We can then apply inference methods to apply this knowledge to concrete problems. The goal of the knowledge-based paradigm is to create a clear separation between knowledge and its use, thus effectively facilitating the reuse of knowledge for multiple problems. In the IDP system, this knowledge in the knowledge base is encoded using FO dot, which is an extension of classic first-order logic, which adds types, aggregates, inductive definitions, and more. This allows us to represent knowledge in a very intuitive manner. The interactive consultant interface is an IDP-based interface, which allows for a user-friendly interaction with knowledge bases. In order to do this, it has some interesting features, namely, the ability to propagate information in all directions. It is able to reason on incomplete data. It can explain the decisions which it makes. It can show which decisions are or have become irrelevant. And we're also able to optimize terms using the interface. Having talked about the basics, we can now go on to talk about the actual DMN IDP tool. DMN IDP combines the readability of the decision model annotation standard with the power of the IDP system through the interactive consultant interface. In the tool, we are able to create our knowledge bases in the form of a DMN model. In this way, the modeling step becomes more user-friendly. Users can create or upload their own DMN models, after which these are automatically translated into FO dot and given to the interactive consultant interface. Because of the flexibility of the interactive consultant interface and the underlying IDP system, DMN models become usable in more situations than just the intended one. On this slide, a pipeline from DMN into the interactive consultant interface is shown. The conversion from DMN into FO dot is done by the CDMN converter, which has been created for a previous publication. We will now show a short demo of DMN IDP. In this first example, we use DMN to create a knowledge base which can calculate the risk level of a patient based on his BMI. This consists of 3 tables, one in which we define how BMI is calculated. In the second table, we use the inputs BMI, so the BMI value, and the sex of a patient in order to define their BMI level. So this is underweight, normal, obese, etc. And then in the last table, we determine their risk level. This is done based on their BMI level, based on their sex, and based on their waist. For example, in this table, if a patient is overweight and they're male and they have a waist over 102 centimeters, then they have a higher risk level. We can now use this specification in the interactive consultant interface. For example, we can insert that the length is 1.79 meters, that a patient's weight is 100 kilograms, and then the system can find that their BMI is 31.2 and that they have an obese BMI level. If we look in the table, we can see that, okay, we calculated the BMI accordingly, and the BMI level, we can trace the rule that had fired, which in this case is rule 7, where the BMI is between 30 and 34, and thus they are obese. If we then also insert that the sex is male and we give a waist, say 94 centimeters, then it can conclude that the risk level for this patient is high, which again, we can see by going into the rules and checking out that an obese male patient with a waist less than 102 centimeters has a high risk level. This could be considered normal functionality for a DMN specification. We go from inputs to outputs. But now that we know that our patient's BMI is bad, it would be very interesting to see what weight he should have in order to be healthy. Using the interactive consultant, doing this is very simple. We simply select that we want a BMI level of normal, which in this case means that the risk level will always be low, as specified by our DMN specification. After setting our BMI level, we set that the length is 1.79. Of course, this doesn't change. And if we now maximize our weight, we find the maximum weight that we would have to be in order to have a good BMI. In this case, 30. Say that we now don't agree that a BMI of 30 is healthy and that it should actually be below 25. Because of the simplicity of DMN, this is actually trivial to change. Here we have Rule 5, which states that a BMI between 30 and 30 for a man is normal. By changing the normal into overweight, and then changing how Rule 3 works, where it says that a man with a BMI between 18.5 and 25 is underweight, we have effectively rewritten that part of our knowledge base. Now, if we were to enter the same information, so a length of 1.79 and a normal BMI level, if we then maximize our weight, we get a weight of 80, which results in a BMI of 25. Behind the scenes, our DMN specifications are automatically translated into FO.DOT specifications, which can be used by the IDP system. Here we can see the translation of the first table, which defined how the BMI is calculated, the table which defined what the BMI level was, and here the table which defined what the risk level is. Of course, there are many more examples in which we can use the interactive consultant interface. For example, here is a DMN specification for the calculation of an American tax form. It starts with a decision to decide whether someone is eligible, and then it goes all the way, it uses all the different inputs, and it ends with a calculation of the refund and the owed amount. Another example is the harbor fuel example, in which we want to first decide whether or not a ship has clearance, whether they're allowed to enter a certain harbor. This is based on their length, draft capacity, and their cargo. And then in a second step, we decide where they are allowed to refuel, whether it be indoor or outdoor. Another example is the vacation days example, in which we try to calculate how many vacation days an employee is eligible to, using their age and years of service as inputs. So, to conclude, DMN allows for a user-friendly encoding of knowledge. These DMN models can be used in more ways than intended. The IDP system plus the interactive consultant interface are able to unlock these usages by allowing reasoning on incomplete data, propagating decisions in all directions, the explanation of decisions, and allowing for optimization. Thank you for your attention. If you have any further questions or you would like to discuss something, you can always reach me at s.vandevelde@kleuven.be. You can try the tool for yourself. You can also read more about the IDP system, and you can read more about the interactive consultant interface. Thank you.